Alright, we have the A puzzle. I'm going to show this real quick because this is my third take and I can't get it in 5 minutes. Alright, so real quick, run the hard problem. Alright, DFS. Boom, shows all the steps, the moves to get there. We're going to stop it because it's going to run for a couple seconds. All of the functions work. I just want to do this fast, so breath for search, boom, there you go, has all the moves, milliseconds, 31 moves, nodes, maximum nodes in memory, problem, 3D best first, okay, and it does take a new input problem too. I'm not going to show that though for sake of time. And there you go, A star works. Alright, now explain the code here real quick. Run through. Apuzzle.java is my main. Obviously run from there. Mostly just a lot of standard output strings, stuff to interact with the interface. And obviously scanner takes the input and calls the appropriate search. So we'll look at search next. Search is an interface. Interface has find solution method, which takes the initial node and returns a linked list of nodes, which are the steps in the solution. It also has a function to get maximum memory. The maximum memory used during the search. We'll go through these one by one. Breath for search, real quick. Standard stuff in here has the queue for the first in, first out, which is how the breath first search works. Returns the linked list of nodes when if it finds the solution. And I guess I'll just say now all of my search algorithms also have a stack. So the breath first search has a queue and a stack. Stack being if the goal is found, when we're traveling back up the nodes, because they'll have access to their parents still, we will throw them onto the stack, and then when we get to the parent, pop them all off the stack, and we'll get the correct order of the solution. So that's the breadth first search. Depth first search is pretty much the same thing. Obviously, instead of the first in, first out queue, we are using the last in, first out stack here. Other than that, very similar. A star. Here a couple things we're doing here is we're setting the f of n flag. That'll make a little bit more sense in a minute, but that's setting a flag in the nodes so that the nodes know that the heuristic is the f of n equals g of n plus h of n function. And so here we have a priority queue so that we can keep proper order for the A star search. And again, we have the stack for the backward solution there. And lastly, we have greedy best first. Greedy best first, pretty much the same. We're obviously not setting the f of n flag here, so in this case, the f of n will equal just the h of n. And same thing, priority queue, and the stack for the backward solution. And lastly, we'll look at the node class. The node class is doing a lot of the puzzle function, I suppose. Implements comparator for the priority queue for A star and greedy best first. Has two hash maps for the cost to get to, and the back reference to states that we've already seen, duplicate states. So this is all being handled within the nodes themselves. There's the f of n flag for the comparator to switch that when we're using the A star versus the greedy. Here's the goal state, final static array list. So all of them know what the goal state is. Constructors, successor function, doing most of the tile logic right here, and this is actually where we are looking for duplicates too. So if I'm getting ready to make a new node, but I've seen it prior, I'm going to handle that at this juncture by well, if I've seen it already. If I've seen it already and it costs more to get to this new child node, I'm not gonna make the node. So there's no reason to look at it. Obviously, I've found a way to get it that's cheaper, so we won't create that. But otherwise, we're creating a new node so that all of the nodes are essentially making a tree to search through. And then go a little further down. Obviously, my successor function is large. I have some accessors and modifiers there. Swap. Swap is called multiple times throughout the successor function to switch tiles, representing the tile switch. Heuristic function. There's our compare function. If f of n flag is on, we're doing heuristic plus the cost. Otherwise, we're doing the difference between the heuristics there to sort. And that's it. Thank you.